Cassidy.
And I'm Kyle.
And we had number 3, and the question was the price, P in dollars, and the quantity, X, sold of a certain product obey the demand equation. And the equation is P equals negative 1/6X plus 100.
Okay, the first A was find a model that expresses the revenue R as a function of X, and R equals X times P. Which means that if we were to find R as a function of X, we would have to plug the equation for P in terms of X in for P in the R equals X times P. Therefore, we get only X's, and then we multiply them both by each other, the single by a binomial, and we got negative 1/6X squared plus 100X equals the equation for revenue as a function of X. And then the second one for the domain, I graphed this equation on the calculator, and I found the two intercepts because that's where you would make absolutely nothing. So we didn't want revenue to be 0, obviously, so it couldn't be equal to. So X is greater than 0 and less than 600.
And then for C, it says, what is the revenue if 200 units are sold? So you plug in 200 into this equation right here, and you get the answer to be 13,333.33 cents. And then for D, it says, what quantity X maximizes revenue, and what is the maximum revenue? And we just plugged, using the equation that we put in our calculator, we found the max on the calculator, and it came out to be 300 and then 15,000. So they sold 300 units. The max you can sell is 300 units, and the max revenue will be $15,000. And then for E, it said, what price should the company charge to maximize revenue? So we used 300 units and plugged it into the very original equation. So we did negative 1/6 times 300 plus 100 equals P, and we got P equal $50. So that's how much the company should charge to make the most revenue.